Okay, what's now? Here one pipe. Oil, this is raw. 925 kg per meter cube is flowing through the pipeline at a constant speed of 4 meters per second. When it encounters a vertical bend in the pipe rising 5 meters, the cross-sectional area of the pipe does not change, and take G to be 10 meters per second square. If the pressure at point A is 2 times 10 to the 5th Newton per meter squared, what is the pressure here? That is the question. Under A. Under B, let's assume that the cross-sectional area of the pipe at point B is now half that cross-section area of here. What is the speed of the oil at point B in that case? And C, what is the pressure of the oil at the point B if the pressure of point A is same as before? Now that is on the same assumption, I think. Okay, first of all, Bernoulli equation is, this is the pressure here, P1 or PA. This is the dynamic pressure, this is the hydrostatic pressure, this is the pressure at point second, somewhere second point, this is the dynamic pressure, and this is the hydrostatic pressure. We call that additional static pressure or whatnot. This is the pressure in the depth, so to speak, of the fluid. So let us see, this is the density and this is the speed. And H2 is 5 meters, H1 is 0. So under A, PA is actually P1, that is 2 times 10 to the 5th Newton per meters. And question is, what is P2? H1 is 0, so place that to be a 0. And speed of the fluid is same. Why? Because fluid does not contract in this situation. And Bernoulli equation becomes, this part of the equation is 0 because H1 is 0. And these two parts is 0 because V1 is equal to V2. So we just removed from the scale both identical things. So this equation here becomes just 1. Here, P1 is equal to P2 plus rho GH2. And we have everything, and now we need to find pressure at point B, or second. And that is 153,750 Newton per meter squared. That is under A. Under B, what will happen if that diameter is half of that? The diameter, let's assume that is first, under A is finished. Under B, let's assume that the cross-sectional area of the pipe is now half. Cross-sectional area is half of that of A. Now let us see what happened with the speed of the fluid. Okay, we now use continuity equation. And continuity equation is cross-section of one place of the pipe times velocity, speed in that. Cross-section is equal second cross-section times velocity in that. And that is under name continuity equation. You could Google that and learn a little bit more about it if you want. And from this equation, simple equation here, V2 is equal to A1 divided by A2 times V1. And you just place in the numbers and you get that actually that is 2 meters per second. So if the diameter of the hole is, not diameter, if the cross-section area of the hole is twice as little as this, then the speed of the fluid is twice as much. You know that when you take gardening hose, and if you want to have longer range, greater speed, you need to reduce the orifice on that hose. The reduction in an orifice will increase the speed and then for the range, but that is something else. And now we have question on the C, and if you want to do that, you could do it yourself, or for complete answer, please follow the link in the description. If you want more of this, please subscribe and tell your friends. Thank you. Bye.